Hello, this is a video to help you study for your Chapter 2 test. So the first problem for us to review is talking about whether a relation is a function. So you can assume it's a function unless you can find a way to draw a vertical line through the shape of the graph that crosses the graph twice. So is this a function? Well, I'm going to start by saying yes, but put a question mark after it. So is it possible for me to draw a vertical line that crosses through the graph twice or not? Well, anywhere I draw a vertical line, it only can cross through once, but never twice. So that means that the answer is still yes, because it's never possible to draw a vertical line that crosses through it twice. So the answer is yes, it is a function. Then number 2 is this, f of 5 plus g of 5. And so first let's look at f. So one of the points that's in f is the point and so then f just keeps on going. So one of the points that's in the function f is the point 5, 4. So that means that when you plug in 5 into f, it'll equal 4 because of that 4 right there. Then the other formula says g of x, actually it just says g equals 5x plus 4. So if I plug in 5, find g of 5, it'd be 5 times 5 plus 4 is 25 plus 4. That's 29. So it's going to be 4 plus 29, and that equals 33. Now let's try problem 3. So the problem says 6x squared plus 10x. So first of all, I'm going to plug in x plus h inside of it because they already have x plugged inside of it. So f of x equals that. If I plug in x plus h inside of it, I would have 6 times x plus h squared. 6 times x plus h squared plus 10. And if I square x plus h, it equals x squared plus xh plus hx plus h squared, which can be reduced to x squared plus 2xh plus h squared. Then remember that there's a 6 in front of that, so this equals 6 times x squared plus 2xh plus h squared plus 10. So if I bring that down again, it equals 6x squared plus 12xh plus 6h squared plus 10. Now it asks us to do this. What's f of x plus h minus f of x? So what that means is, that I'm going to take this part, so 6x squared plus 12xh plus 6h squared plus 10, and then I'm going to subtract that part. It's going to be minus 6x squared minus 10, because if you subtract a positive 10, you get a negative 10. And then that equals that cancels out, and so that equals 12xh plus 6h squared. And then our last and final step is we're going to do f of x plus h minus f of x over h. Well, the top of it is equal to 12xh plus 6h squared. The bottom of it is equal to h. And on the top of it, I can factor out a common factor of h, leaving me with that. And now the h crosses out, so oh, you know what? I made a mistake. At the beginning of this problem, there was actually a 10x. So just a second. Well, I'm almost finished. So this equals 12x plus 6h. Now I did make a mistake because in the original problem, this problem actually said 10x right there. And so if that said 10x, then right here, you would have plugged in x plus h beside the 10, and that would have equaled, if you distribute the 10, you'd get 10x plus 10h, like that. And so at the end of this, you'd have plus 10x plus 10h. And then over down here, you would have had 10x plus 10h. And then over here, you would have had, instead of minus 10, you would have had minus 10x. So this minus 10x would have canceled out the positive 10x. And so you would have ended up with 12xh plus 6h squared plus 10h. So I left off the 10h because I didn't write the x at the beginning. And then, so if you factor out an h from the 10h, you'd be left with positive 10. And then you would have had an extra positive 10 at the end. So I actually did two problems for you. I did the one that I made a mistake of writing down. And then now I'm also doing the one if there's an x in it. So I'm not sure which one you'll actually have on your test because it's random. But if there is an x at the end of your problem, then you will end up with this for your answer instead of the other answer. All right, so now let's try number 4. So 9 over x, and we're doing the same thing, so we're going to plug in x plus h inside of it. So plug in x plus h for the x, and then you subtract the original function, and then you have it over h. So then what you do is you find the LCD, which the LCD is x plus h times x. You're going to multiply on the top, both parts of the top, you're going to multiply by the LCD, as well as the bottom, every part of the bottom, every term in the bottom, you'll multiply by the LCD as well. Now what happens is this x crosses this one out, this x plus h crosses this one out, and then you multiply it. X times 9 equals 9x, and then negative 9 times x plus h equals negative 9x and negative 9h. And then in the bottom, you don't do anything. You want to save the h that's on the outside. Now you can cross out this 9x and this negative 9x, and then you can factor out the h. That leaves you with negative 9. Now you still keep the h on the bottom factored out. Then you can cross that one out. So the answer is equal to negative 9 over parentheses x plus h times x. All right, perfect. So now let's try to do problem 5. So it says the cost of the meat in the bun for a burger is equal to 60 cents for each burger. So it's 0.60x, because x represents how many burgers you have. Plus it also costs $20 for more supplies. So the answer is 0.60x plus 20. That was simple. All right. Now we have the next problem, 6. So this says x equals y squared plus 11. So we're going to complete a little table. So when y is equal to negative 2, negative 1, 0, 1, and 2, when you plug in negative 2 for y, you have 4 plus 11 is 15. Then when you plug in negative 1 squared, it's positive 1 plus 11 is 12. 0 plus 11 is 11. 1, when you plug in that for y, you get 1 plus 11 is 12. And when you plug in 2, you get 4 plus 11 is 15. So x equals all those different numbers. So if you graph the graph of it, that'll look kind of like this. So your x, so it starts out at 11, 0, 11, 0. Then it goes to 15, negative 2, and then 15, 2 as well. So the graph looks like that. Now notice closely that the left side of the graph is at 11, and it does touch 11. So the domain of it is from left to right. It's 11 with a bracket around 11 to infinity, and then the range of it is from the bottom to the top. So the bottom of it is going downwards to negative infinity, and the top of it is going upwards to positive infinity. So that's the domain and the range. And is it a function of x? Well, normally we say yes, it's a function, except in this case, if you draw a vertical line through it, you can touch it more than once. So that means the answer is actually no. No, this graph is not a function of x. All right, now let's try to do problem number 7. So first of all, what we're going to do is we're going to plug in 1 into the top formula, but when we plug in 1, we're going to make an open circle because this inequality does not say equals. So I'm going to plug in 1 for x, and I'll get 1 plus 4 is 5. But that's an open circle. Now I'm going to think of a number that is bigger than 1, like 2. I'm going to plug that into the first problem. 2 plus 4 is 6. And that's true, so that is a closed circle, because 2 is bigger than 1. So I'm going to draw this starting from the open circle at 1, 5. So there's an open circle at 1, 5. And then there's a closed circle that's at 2, 6. Then I start from the end of it, which is the open circle, and I go that way. So that's the way that part of the graph looks. Then I go to the second half of the graph. This second half of the graph says less than or equal to 1. So I'm going to make another table, and I'm going to plug in 1. This time I'm going to plug 1 into the second formula, which is x minus 2. So 1 minus 2 is negative 1. And then I think of a number that is less than 1, like 0. If I plug 0 into it, 0 minus 2 is negative 2. So I get 1, 1, which, by the way, 1, 1 is closed because notice the inequality says it can equal x equals 1. So it's going to be closed. And the other point is also closed because that's also true as well, because 0 is less than 1. So I'm going to plot 1, negative 1, which is right there with a closed dot. And then I'm going to go to 0, negative 2, which is another closed dot. And then I'm going to start from the first closed dot and go that way, because the first one is where it begins. So that's the way the graph of it looks. And the domain of it goes from negative infinity to infinity, from the left to the right. And the range of it goes from the bottom of the graph, which is negative infinity, up to negative 1. And it touches negative 1 and then stops. And then union. And then it starts out at this point right here, the open point, which is 5. But it does not actually touch 5, so there's a parentheses there, and then infinity. So that's the domain, and that's the range. All right, now So first of all, number 8, you have a graph that looks like this. And if you look carefully at that first point, I recommend that you label it -2, 3, and this point is 6, 3. So, and the midpoint of it, where it reaches the highest point, is at 2, 7. 2, 7. So the domain of that first one is from left to right. So -2 to 6. The range of it is from bottom to top, which is 3 to 7. And then it's increasing from here to here, right? And that's increasing from x equals -2 to +2 from left to right. So -2 to +2. And then it's decreasing from there to there. So from 2 to 6. All right, and is it constant? It's not actually constant, so never constant. Constant means flat. Well, constant means straight and flat. So it is flat at the top for just a second, but it doesn't actually straighten out though. All right, then there's actually a second part to this question. It looks like this. That dot is at 6, 3. And this dot right here is at -1, 3. And then there's an arrow at that end. So let's answer the same questions for this problem. What is the domain? So from left to right, the left side of it is at -infinity. The right side of this is at 6. So the domain of it is from -infinity to 6. The range of it is from bottom to top. The bottom of it is at -infinity. The top of it is at 3. And it's increasing from on this area right here, right? So the left side of that area is -infinity. The right side of that area is at 3. No, actually, I'm sorry. The right side of that area is it's the x value that matters. So the right side of that area is at -1. And then what about decreasing? Is that function ever decreasing? No, it's never decreasing. How about constant? Yes, it is constant. It's flat. So it's constant. It's constant from x equals -1 through x equals 6. So that's that one. Okay, then let's try number 9. So y equals x squared, and we want to move it 3 units to the left first. So to do that, we're going to put x minus 3 on the inside. Oh, I'm sorry, that would actually move it to the right. So let's make it be x plus 3 on the inside. That moves it to the left. And then to move it 2 units upward, so that moves it 3 units left. Then to move it 2 units upward, we're going to add 2 to the outside of a function. So when you add something to the x value inside the function, it moves it left. When you add something to the outside of a function, it moves it up. So that's going to be the answer to that problem. And then number 10. So 10 says y equals -1/2 absolute value of x plus 5. So first of all, what you're going to do is, this is a shift left 5 units left. And then this is a vertical stretch or shrink of 1/2. And then this negative sign is that's a vertical reflection about. Vertical reflection is always reflection about parallel to the x-axis, right? So it's a reflection across the x-axis, or about the x-axis. So there we go. So that's the answer to that question. And then what you'll do is you'll use the graphing tool on the computer to enter in you'll choose the parent function like this. Then you'll enter in those different options into it, those transformations they're called. And then when you do that, it'll automatically shift it over to the right place. Okay, then the domain of it is going to be, so let me show you how it looks really quick. So if I could draw a graph of it, it'll be left 5 units, 1, 2, 3, 4, 5. It'll be shrunken to be 1/2 times as tall, which will make it look kind of wide. And then it'll be opening downwards, like that. That's the way that it'll look. And the domain of that is from -infinity to infinity is the domain. The range of it is from the bottom to the top, it's -infinity to 0 with a bracket on the 0 because it does touch the point 0. All right, so now let's try number 11. So 11 says y equals -square root of x minus 5 plus 5. So this moves it right 5 units, right? This reflects it across the x-axis. This one moves it upwards 5 units. So if I make a graph of it, the original square root of x looks like this. So if I take that graph and I move it right 5 units, 1, 2, 3, 4, 5, like this, and then I reflect it across the x-axis, so it would look like this. Then I move it up 5 units, 1, 2, 3, 4, 5, so it looks like this. Then it's going to look like that. And so your final graph looks kind of like that. Now notice, if your computer doesn't show enough of the window, your computer screen might only show this much of the window, so your graph might not actually go below the x-axis. If your computer screen shows a lot of the window, then yes, it will go below the x-axis. But if your computer screen only shows a little bit of it, then it might look like that part. You might not be able to see the part that's over there that actually does go down below the x-axis. That's just something to watch out for because it's a multiple choice question. And so now look at that green part. So look at the green part. The blue part, I'm sorry, the blue one. The blue one is the final answer. So what's the domain of that blue graph? Well, the left side of it starts at 5, right? And then it goes to infinity on the right. The range of it from bottom to top, the bottom of it is at -infinity. The top of it is at 5. So that's the domain and the range. Okay, then number 12. So take the formula y equals 2x to the 4th minus 3x to the 3rd. And is it symmetric about the y-axis or the origin? So notice this is an even power. This is an odd power. When you add or subtract an even to an odd, you get neither. So this is actually neither symmetric about the y-axis or the origin, and it's also neither even nor odd. So that one's neither. Okay, now let's look at number 13. So x minus 4 squared greater than 2. So first of all, we need to set this equal to 0. So if I square the left side, I go x squared minus 2 times -4 times x is -8x plus -4 squared is 16. Then subtract the 2. Then you get 0 on one side. Then you can use the quadratic formula, so it's -b plus or minus the square root of b squared minus 4ac all over to a. So we'll get 8 plus or minus 64 minus 40 plus 656 over 2. So that's equal to 8 plus or minus square root of 8 over 2. And the square root of 8 reduces to 4 times 2. So it's the square root of 4 times the square root of 2. But the square root of 4 is just 2. So that actually breaks down to 2 square root of 2. Then you can factor a 2 out of the top. That leaves you with 4 plus or minus square root of 2. And then 2 in the bottom. So that crosses out. And you get x equals 4 plus or minus the square root of 2. So I'm going to erase this left side. And then I actually need that part that I erased at the top. So x squared, yep, there we go. So I'm going to draw a number line now. So you're going to have x equals 4 minus the square root of 2. And then you're going to have x equals 4 plus the square root of 2. So what happens is, now you look at the leading coefficient. There's an invisible 1 at the front of the problem. So when the leading coefficient is positive 1, that means the right side of the graph is equal to positive. The right side of the graph is positive. So on the right side, I'm going to make it go up. Then, since there's 2 different solutions, it's going to change signs at each of those. So they each have a power of 1 or multiplicity of 1. So we're going to draw through that. And now we're solving the equation when it's greater than 0, which would be this part and also this part. And greater than 0 means that when it's equal to 0, that does not work. So those 2 points are out. And greater than 0 means when it's less than 0, it does not work. So that part is out. So the answer to the problem is this little region right here and this little other region right there. So it's going to go from negative infinity to 4 minus the square root of 2, parentheses, union, and then it's going to go from 4 plus the square root of 2 to infinity. And that is the solution. Now let's try problem number 14. So that's f of x, and this is h of x. So what is f minus h? It would just equal the square root of x minus 1 over x minus 1. That's all. That simple. And the domain of it, okay, that x value cannot be less than 0, right? So it has to be at least 0 or bigger, right? And then this x value right here, this x value right there cannot equal 1. So it can't be 1. 1 is not allowed. And it also has to be bigger than or equal to 0. So if it can be bigger than or equal to 0, but it cannot be equal to 1, then you're left with this little region and this little region. So the domain of it is from 0 to 1, parentheses, union, parentheses, 1 to infinity. Perfect. Now let's try 15. So problem 15 says f of x equals 5x plus 1. G of x equals square root of x. So what is f of g of x? What that means is you take the g, you plug it into the function f. So that would equal 5x plus 1, but instead of saying 5x plus 1, you take away the x and you plug the function g inside of it. So the answer is 5 square root of x plus 1. Perfect. Now let's try 16. So f equals absolute value of x, g equals x minus 4, and h equals x to the third. So, and now the function is x minus 8. The new function called capital N is x minus 8. So how could you get x minus 8 from those three functions up there? Oh, I made a mistake, sorry. G, I wrote G down wrong. G is just x minus 4. So notice that G, what it does, G just subtracts 4 from whatever you plug into it, right? So if I subtracted 4 from something, and then I plugged it into the function again and subtracted 4 again, then I would have had a total of subtracting 8, right? So G of G is the answer because G of G equals x minus 8. All right, then let's try 17. So 3x cubed minus 3x, which looks like this. So is the function 1 to 1? Well, to find out if the function is 1 to 1, you do the horizontal line test. So you're going to assume it's yes, unless you can draw a horizontal line that touches it more than once. So if I draw a horizontal line through there, it does touch it more than once. So now the answer changes to be no. So the answer is no, this function is not 1 to 1. No, it's not 1 to 1. All right, then number 18. So look carefully at number 18. There is a diagonal line through the middle, and then there's a line that looks like this. And then there's a line that looks like this. That crosses through here and comes out there. Now, according to what I've drawn, those two graphs are a perfect reflection across the diagonal line. So if they are a perfect reflection across the diagonal line, then the answer is yes, those two graphs are inverses of each other. Okay, now let's try problem 19. Problem number 19 says y, or f of x, which is the same thing, equals 7x minus 2. So we're finding the inverse of this. So first of all, you change y to be x. So next you get y by itself. So I'm going to move the 2 over. Then I'm going to divide by 7. Now once y is by itself, then the last step is you change the name of it to be called f inverse of x. So f inverse of x equals x plus 2 over 7. Now let's try problem 20. So this one says y equals 3 plus square root of x minus 4. So change the y to be an x and the x to be a y. Then move the 3 over to the other side, and then square both sides. And then add 4 to both sides. Sorry, it's negative 4. So then move the 4 over to the left side to become positive 4. So that's the inverse. And that inverse is only valid if the left side of this equation right here is positive. So this is your answer right here. F inverse of x equals that. But it's only valid for this as a square root that can only be positive. And so that means that x has to be greater than or equal to 3. All right, now let's try problem 21. So this one says y equals 7x plus 7 over 9x plus 8. So first step is I'm going to change the y to be x and change the x to be y and also change that x to be y. Now pay close attention to this one because this one is a little harder than the other ones. So first you have to take the bottom of this, cross multiply it up times that x. So x times 9y is 9xy. And then x times 8 is 8x. Then write the other side. Now get the y's together. So I'm going to take the 9xy, leave it right where it is, but then the 7y, I'm going to move the 7y to the left, which makes it negative 7y. Then I'll leave the 7 where it is, but I'll move the 8x to the right, which makes it negative 8x. And then I'll factor out the common y that I have in common. That'll leave me with 9x minus 7 equals 7 minus 8x. Last step is I'll divide this number, or that factor, underneath the other side, underneath that side. So the answer will be y equals 7 minus 8x over 9x minus 7. So that's the inverse formula. Now let's try problem 22. So that was 21. Now let's try problem 22. So this one says y equals cube root of x minus 1. So I change that to be x equals cube root of y minus 1. Then this time you cube both sides. So x cubed, and the cube cancels out the cube root. So you get x equals y minus 1. Then you just add 1 to the other side. X cubed plus 1 equals y. So that's the answer. The inverse function formula is x cubed plus 1. Then 23. So f equals 3 over x minus 4. G equals 3 over x plus 4. Now the funny thing is if you plug in this formula into this formula, or if you plug in that formula into that formula, either one that you plug in, you'll just end up with something amazing. Like for example, if I take 3 over x, but instead of saying 3 over x, I say 3 over 3x minus 4 plus 4. So what I'm doing now is I'm plugging in this formula into that formula. Well, when you divide by a fraction, you just flip it over and you multiply, right? And then the 3 cancels, and then you get x minus 4 plus 4 equals x. So either way you do it, you'll get x. Both times, you'll just get x. And when that happens both times, that means that those formulas are inverses of each other. They are inverses of each other. Perfect. Now let's try 24. So problem 24 says t is equal to proportionality constant, inversely means divided by y, and then it says t is negative 50 when y equals 2. So now cross multiply by the 2. 2 times negative 50 is 100, negative 100. So that's the constant of variation is called that. And then the formula that represents the statement is t equals, the constant is negative 100 over y. So this is the formula that represents the statement. T is equal to negative 100 over y because k is equal to negative 100. All right, then number 25. So determine whether the first variable varies directly or inversely. The length of a car in inches or the length of a car in feet. Do you think that those vary directly? Well, the more feet long your car is, the more inches long it is, right? So that would be directly. That would be directly. Then, what do you think would be a relationship between them? Well, directly means that inches equals a constant times the feet, right? So that would be your answer to that problem. Now, 26. So the time required to process a shipment of oysters varies. That means it's a constant. Directly means multiplied as the number of pounds in the shipment and inversely with the number of workers. So 4,000 pounds can be processed by 8 workers in 8 hours, right? So now cross multiply by, actually divide the 8 up into the 4,000. 8 goes into 45 times, so that's 500. So 8 equals k times 500. Now divide by 500, so 8 over 500 equals k, and 8 over 500 can be reduced by 4 to be 2 over 125. And then once again, we'll write the formula. The time required is equal to the constant 2 over 125 times the people divided by the workers. Not the people, the pounds. Multiplied by the pounds divided by the workers. So how long would it take 5 workers? How long would it take 5 workers to process 4,500 pounds? So 5 workers, 4,500. Well, then the time required would be 2 over 125 multiplied by 4,500 divided by 5. So let's see. First of all, 5 goes into 4,500. 5 goes into 45 9 times. So that would be t equals 2 over 125 times 900. And then, let's see, 25 goes into 125 5 times, and 25 goes into 900, let's see, 36 times. So we would have 2 times 36 is 72 over 5, and 70 divided by 5 is 14. 2 divided by 5 is 0.4, so it would equal 14.4. 14.4 hours of time. So I hope that helps you as you're studying for your test in Chapter 2. Very best wishes to you.